final project for Mech 3380. So just a brief introduction to the problem. This part is used in a mechanical stylet used for endotracheal intubations. I can't show the full assembly. However, this part is used to pull up a wire that allows for tip deflection. So there's a shaft that goes into that large square hole, and then a wire that goes into that circular hole over at that like square end of the tip. Um, and this needs to fit within certain dimensions to avoid collisions with parts. And the goal is to minimize volume to reduce manufacturing costs. So first of all, the geometry and the constraints of this is the lever has a maximum force of 5 newtons applied on the end. It must be at least 1 millimeter to account for that circular hole that the wire goes through, and a max width of 2 millimeters to avoid any collisions with parts. Its radius at this end also needs to be between 2 millimeters and 4 millimeters, also to account for that square hole and collisions with parts. And because this is made of ABS, the max stress it can experience is 35 MPa before yielding, and that'll be our upper limit for stress. And then during the simulation, it gets fixed at that square slot just to maximize uh, the stress from the force getting applied perpendicular to the axis. So, so the design optimization statement is the volume of the part needs to be minimized to help save manufacturing costs while the max stress remains under 35 megapascals and the width remains between 1 and 2 millimeters and the radius remains between 2 and 4 millimeters. So here is the Taylor series used for volume. This was derived using the table on the right. And then the constraints it must follow, the width, and then the radius, and then also this is the inequality constraint for the stress, which also came from a Taylor series from the data on the right. So when running the simulation in SolidWorks, I fixed the square slot on the left and then applied a load to the top of that square end on the right where the circular hole comes out of. Uh, so after optimizing it using MATLAB to get the optimized values, it decreased the volume and increased the stress, which is what we were looking for. Uh, However, the issue was it probably could have optimized it more. If you see the stress only capped out at 7.8 megapascals when we were shooting for a max of 35 megapascals. Uh, and I believe part of this was I should have used a second order Taylor series when running the optimization. However, the design was optimized, but I do believe it could have gone further. Thank you.